because our first speaker is our first international speaker. It's Opheim from Norway, and let's applause. Really great. Really first speaker who will speak English in our meetups. I'm absolutely sure that he is not the last English speaker here, but it's really great that someone from so far away from Norway will speak here for you about how to test properly your legacy code. So let's.
Okay. So, welcome everyone. It's a pleasure to be here. It's an honor to be the first person giving a talk in English for the Nobel Prize. My name is Mats. Yeah, what we done? Start by saying hi, I guess. Yeah, my name is Mats. I'm from Norway. I work in a Norwegian consultancy company called Computas. We're based in Norway, Denmark, and Romania, so it's not strange if you haven't heard of us. No, you have. So today I'm going to talk to you a bit about lots of things you probably know beforehand, or like concepts you already know about or maybe use, but I try to set them in the context of testing, which has been very useful to me to think about like old concepts, new framings, which is what I'm trying to do here. And by the way, if some of you are wondering why in all worlds you come all the way from Norway to Novosibirsk to go talk to the meetup, how many of you went to that question now? Yeah. So a couple of guys, okay. So me and my friend Elias sitting over there, we are traveling on the Trans-Siberian Railway. Like, we came from Kazan yesterday and we're heading on to Irkutsk by car tomorrow. So when I thought that, okay, when in Novosibirsk, what do you do? Why do you go to meetup? So with that said, don't repeat yourself. Just jumping right straight into the content here. And by don't repeat yourself, I guess that most of you are programmers, developers. You already know this principle, right? When you're writing code, don't repeat yourself, don't write the same code over and over again. Don't have several different implementations of the same concept unless there's a specific need for it. So familiar, right? But with testing, and especially with like system testing or system test phases or end-to-end testing or all these things, when you do manual testing, we seem to forget this principle. We seem to forget the driving principle when we are doing manual work. Like, why should you test a feature over and over again doing manual testing? Which, to be honest, I find manual testing to be really boring. Like opening the application, clicking around, following a script, all this, I find that to be really boring. But on the other hand, I like to create great software with few bugs and that does what the user needs. So that took me to the world of automated testing. Because I've been working with spaghetti code. If this picture is a bit unclear to you, that's perfectly fine because it's meant to be. Because this is a bit unclear, it's hard to see which parts are connected to which parts, like how the spaghetti is connected and so on. Like, so if you want to take one single piece of spaghetti and just extract that one, how do you do that? Right? It's really hard. Because it's unclear, so it's hard to see what is connected to what, and it's also really tangled. That every piece of spaghetti is really tangled with the other pieces of spaghetti. And I've worked with quite some code that has the same characteristics. So you might wonder, is spaghetti code really another word for legacy code? I would say yes. So what do we do about that? Well, as this talk is named 9 ways to test the spaghetti code, it's surely no surprise to you that I'm going to give you 9 tips, 9 techniques, and probably a few more as well. So let's hit straight into the first one, which is the old familiar, hopefully familiar, potentially familiar test pyramid. Like when the theory says that you should have lots of unit tests, quite some integration tests, and a few end-to-end tests, and some manual testing, like in a strange shape on top of that, in a kind of a cloud. Like in this context, I brought the test pyramid into it just to see and to show you that sometimes it's easier to write unit tests, sometimes it's easier to just attack it from one side, just an end-to-end test. And when getting control of legacy code, like I tend to say do what's easiest, like from time to time. So sometimes you can write unit tests, sometimes you can end-to-end test, both things are fine. Yeah, set your dependencies. Oh, another like typical concept in software engineering, but still very useful for testing purposes. So yeah, I'm a Java developer. What you would probably guess is related to the JUGNsk. Yeah, it's like use dependency injection. Like this the Java E style we inject and the EJB. So you can do this several ways. Like I've done here with center methods, you can inject directly on the variables, or even better, perhaps in a constructor. Doesn't really matter from testability point. And this is also a step in untangling your code. When you're doing this, you're untangling this class that's surrounding this from the document generated document manager. So it's also a way to like improve the design of your code. And here's what you can do in a test. By the way, those words you don't understand, they're Norwegian from the Norwegian domain, so don't worry. So yeah, here's what you can do in a test. Like just set. And there are tools that can do this for you. Yeah, like another thing we all probably learned at university. But like I don't think we follow it in this context. Like when you're using interfaces, what you really are doing is you're explicitly saying to the ones using your code that, hey, here's what I intend you to use from this class. These are the methods I intend you to be using from my class. They show up in the interface. So like just to show you some more code from our project, like to the upper left you have the implementation, and to the down here to the right you have the interface. So you can see that the implementation has lots of methods and lots of inputs and parameters and all of this, while the interface is just one single method. And whenever you need to, in your tests, need to mock out these things, it's much easier than just to create the implementation you want from an interface than to handle all of that up there, writing and such. Yeah, and another aspect is like whenever I see lots of method names, my brain starts working on it. My brain starts processing it as I'm figuring out, like not conscious at all, but as I think, okay, what does this method do? What does this method do? How are they connected? What about? So like you start digging into all these details. Like it's really unconscious, but at least I do that. So it's like when I see this only see a single one method, there's not that much. My mind can't wander that far. Simply. Yeah, okay, so don't shoot me. Singletons. Like, which is, it's a hot topic in many developer communities, and that's perfectly fine. And like, I'm not saying anything neither for nor against singletons today, but like, if you are a legacy project, chances are that there are lots of singletons. Yeah, some of you are nodding, getting those feelings. It's like, whenever you have lots of singletons, you have to handle them. You have to handle them in your tests. Which, luckily, most of the time ain't that hard. Like if you define power with the single channel length, where you have one single instance of, for example, a session manager, and you access it by a static get method, and you also have a static set method. And in your test, you can just set it to be whatever you want it to be. And like you get some problems with things like threading, like if you're running tests in several threads, or if you're running several cores, or like build parallel building on this like parallelization issues. But, yeah. and also a cleanup afterwards, so that the next test isn't affected by the set from previous tests. But these are things you can handle, I think. Okay, yeah, yes, that's tip number 3. We should speed up a bit. Okay, package protect problematic parts, which is a hard way to say. Whenever you have something that's problematic, I think it's been nice to just extract the problematic part, like problematic from a testing point of view. Just extract that problematic part into its own method, make it package protected, and now you can override it in a test class. So like, it's typically used for things like displaying windows, that we're doing here, or like awaiting user input, calling some async things, static methods, whatever, like all of the things that when you're writing a test, you think that, oh, this is hard to test, then you can hide it in its own method and override it. And you can say that, well, what's this does doing the design of my code? Isn't it like just an extra method with an extra layer? And in a sense it is, but it's also an indication that the class you're working on might have, or the method you're working on might have too many responsibilities to begin with. So that in the long run, it actually points out the way you should do further refactoring, which direction you should head in. Yeah, mockito, it's a great tool, I think. Many people like it, many people don't like it. Both things are perfectly fine, but it's a tool that has made it much easier for me at least to write unit tests for lots of code. Like with mockito, you can, when you have a class, you can just make a dump version of it, like with the same signatures and so on, that just does nothing, returns default values. Or you can say that you can spy a class, spy an instance of a class, so that if you have a session manager and you can spy on that, you can say, okay, behave as normal, but in this specific case, do this. Like record how many times these methods are called. You can do lots of cool things with mockito. And if some of you using Kotlin, I think mock K is the Kotlin version. I haven't used it myself, but I think it's pretty much the same. Yeah, and don't overuse it though. Like the moment you figure out that, okay, now I mock this, and I mock this, and I mock this, and I'm starting to be confused, and like I don't even remember how things are connected anymore, then you're probably done too much mocking. Don't do that. Yeah, all of the things that we're talking about, they have in common that they are tools that you should have in your toolbox that are sometimes usable, sometimes not. Like, the more things you know, the more techniques you know, the more tools you know, patterns and so on, the more you can apply them when suitable. And the more you have a feeling of, is it suitable now? Yes, no. Yeah, tip number 4, consider removing final and static. And by that I mean, if you have methods or classes in your code that's final or static methods, they can also be hard to test. And if they are hard to test, well, one way to make them easy to test is to remove final, remove static. If they're final and static, you can't mock them, you can't override them in your test classes, you can't do anything fun with them without like going to a bytecode hacking level kind of things, which you should avoid, I think. Even though it might be fun. I guess that might, yeah, I guess there are some here in the audience that finds it fun to play with bytecode, but probably not for production. In many systems. Yeah, so in general, like, what you should do is untangle things and yeah, hopefully look at things one part at a time. Try to like untangling. It's big. Like if I were asked like what's the single one thing that I'm doing to get code on the test, I would say it's untangling. Because like you're not as smart as you think you are. I guess that most of you developers think that okay, so now I'm doing this code change. So like I'm doing a change to this 300 line long method and this 20 line long method, and I do some changes in the contracts between those methods. And yeah, I can handle that because of course I can remember like 20 variables and make sense of everything and make everything sound nice in my head. and then after 20 minutes or like hacking on, someone comes approaches you and asks you a question about something unrelated. 20 seconds later, you've forgotten everything and start over again. But if you realize that you are not, if you use your brain power not on remembering names of variables and such, but if you're using your brain power just on exact single one thing you're doing, it makes it so much easier for you. Yeah, so do simple refactoring to get your code on the test. And why do I even mention that? Well, because Michael Feathers says in his book that legacy code is code without tests. Like, whenever you're doing changes to code that isn't tested, you can break something without noticing it. Of course, you can break something if you're changing code that is tested as well, but then hopefully your testers will notice it. So, but sometimes you just have to do some things to get your code at the test, like remove final or make a private method public or some things like that. That would be perfectly fine. But do as little obviously. Do as little of it as you can. Yeah. So next one, functional programming for the win. And by that I mean there are several things from functional programming that we should take into account when you're writing Java code, I think, which is the direction Java has been going in for the last 5, 6, 7 years, from Java 8 and onwards. When it comes to streams, optionals, and more things that originated from the functional programming world. And also we should take the habit when programming when doing, if we can do stateless programming, that's great. That's like one less thing that could blow up. Or like if you have a method that has no side effects, well, the only thing that can go wrong then is that you get the wrong answer, right? That's the only thing that can blow up if you have a side effect-free function. Or if you have immutable objects, that's another problem you don't have to think about. If your objects are immutable, you don't have to worry about someone inside this 300-line method changing something. That's not possible. Like functional programming, or techniques from functional programming can dramatically reduce the number of things you have to think about when you're writing Java. And everything you don't have to think about is great. Yeah. But like, why am I not speaking so much of testing? Why am I speaking of software design and software design principles mostly? Because not much of what I've been talking about so far has been about testing as such, right? It's been mostly about design code. And what I find is that there's a strong correlation between well-designed code and testable code. So that I think that the solid principles are great. That a class following a single responsibility principle is better design and it's better, more testable. The same with shorter methods, dependency injection, and so on. Interfaces as well, great. So there's a correlation here. Right. Tip number 5, help your team. And by that I mean it's great if you are the one person on your team that writes lots of tests. That's great. Continue doing that. But like if you're the only one of 5, 15, 20, it doesn't really matter that much. Like bring your entire team on board. And what I found with that is that if it's hard for people to get started writing tests, people will have a higher, but that will reduce the chance that people actually are writing tests. If it's like 20 minutes of work just to instantiate an object and to test, people won't do that because they have typically lots of work to do, right? But if you can make it easier for them, so like that starting writing tests is easy, well, people do it much more. Yeah, and of course, whenever you have learned something, teach it onwards. Yeah, and by the way, you will forget things. Speaking of helping your colleagues, you can also help yourself. Because like the code you write today, no way you will remember all the details about that code in 2 years, or even 2 weeks. You will forget some things. And you will forget why you did things. You will forget why did you do this, why not that way. You will forget the corner cases, because you still have new things to learn, new things to pick up, new features to work on. So you can't all the time keep up with the old things you've done. And by that, I mean, well, write your code in such a way that you know that you forget things, like write your code that way. That goes for variable names, that goes for length of methods, class names, package structure, like all these things, so that you don't have to remember everything about it the next time you see it, but you can understand it and see the patterns instead. And of course, that's if you are coming back to your code, but what if you already have moved on to the next job, next project? When some cool developer in 5 years comes to see your code and, oops, what's going on here? Like, tests with sensible names and proper implementations can also be great as documentation. And it's the least boring way I know of writing documentation as well. It's a bonus. Yeah. So I admit we are screwed up on this one. Run your tests and care about the results. Like, I guess that most of you have a build system which automatically runs your tests, like Jenkins or TeamCity or I don't know what it's called anymore. But I guess you already have that. Like, also get that some of you don't really care if the tests are failing. But if the test is failing, you can say, oh yeah, but it's failing because it's Monday and it fails on Mondays. Yeah, we have those. Or like any kind of these flaky things, so that tests that fail every now and then. So that you get used to that your build is broken. You get used to that you can't trust it. And if you do that, what's the use of your test then? Like, if your test is green, then all is good. It's working. If your test is red, something is broken, you should fix it. Like, it should be so easy. And if you have some tests that fails without any proper reason, that just fails because it's flaky, then you should either fix it or delete it, because it doesn't provide the value. And people lose trust in tests. You know, some of you perhaps know the principle of the broken window theory. Like, if one window in the host is broken, the chances are that people will break the rest of the windows as well. Like, the moment you fix the window or just put some paper on it, like showing a way that you care about it, then they will stop. Then people won't break the rest of the windows. It's the same with code, I think. The moment you have one failing test, you suddenly have 1, 2, 5, 7, 70. No one cares, right? Yeah, feature tunnels. So feature tunnels, it's very useful for things like A/B testing, like introducing a feature to 1%, 10% of the users, or like if you're writing a new implementation along with the old one, you can switch between them. So whenever you're ready, you can create a new function. But it can also be great for testing purposes. And here's an example. Some of you might know this Swing utilities. Yes, I'm working on Swing project. Java Swing, yes, we're a legacy. But in Java Swing, you have this invoke later, which says the invoke is runnable whenever the Swing GUI is ready. Which is nice in real life, but hard, like it's not deterministic in the test. So in the test, we do have this feature of headless. So like the test run headless. So if one test tries to open a graphical window or wait for user input or anything like that, the test fails, it throws an exception. But that also means that you can do things, you can use that for handling things differently in your tests than in your production code, which is something you definitely shouldn't do often, but sometimes it's useful. And you can also do things like having a specified menu. Yeah. Let's move on. Okay, 1 mile at a time. By that, I'm not advocating that you should go home now and write tests for all your code, all your spaghetti code. I guess you can do that if you have lots of time. Developers rarely have lots of time. But if you do, every single time you change some code, you write some tests for it, every single time you add a new feature or you refactor some code, you add test for it, you improve the tests. Well, in time, you will have a stable system. Not okay, you wouldn't necessarily have a stable system, but you will have a well-tested system with lots of tests and which we constantly have an improving quality. And another fine thing is that, okay, don't say this to your manager, but if you do the refactoring and then test 1 mile at a time, then no one will stop you from doing it for budget reasons or such. If you go to your manager and say, hey, I'd like to use the next 2 weeks writing tests for the code, chances are you'll get no. But if you like at every single feature, every single item you work on, you do some improvements, no one would notice. Like they want the time for it. Yeah, and it's low risk as well. Because then when you're doing changes, you know what you're doing. You know that part of the domain. Or at least you get to know it. But yeah, whenever you refactor, do that in separate commits. That's just, I'm doing quite some QA and pull requests on my team. Like, it's some, whenever you mix up refactoring and actual changes of behavior, that's hard. But if you do refactor in separate commits, it's so much easier to read the code, commit by commit. Okay, so customer development. Yeah, okay, tester development shortcut, like you write a fatal test, you do whatever you have to do to make the test screen, and then you refactor the code, and then you do it over and over again, which is a habit that makes you write tests. And I find that, to me, it makes me write easier code because I'm lazy. As a developer, I'm lazy. I'm not willing to write more code than I have to, like more stuff than I have to. So whenever I write the test first, I do exactly what I need and nothing more. And it gives me immediate feedback. Like the time from I've written the test to know whether it's working or not is really short. Whereas in a legacy system, you might spend minutes starting the application or starting the application server, running mail and builds or anything like that. With a test, you can get immediate feedback because it's a unit test. Yeah, okay, so test-driven spaghetti, because like we all know about test-driven development in Greenfield, right? In new projects and so on. But when you're working with spaghetti code, how do you do test-driven development there? It's a question I get often, and like the more I think about it, the less answer I have. In the sense that what I do when I do TDD on spaghetti code is that well, I do TDD and I test spaghetti code. It's like those two things combined. Nothing more magical than that, I think. Like, yeah, you must, of course, do TDD, and you need to know how to test the spaghetti code. And if you do that, it's like, whether you write the test first or after, that's a bit the same, I think, in the hardness way. So it's not, there are no secrets. I don't have a secret unicorn or anything like this. Do TDD and keep it going. Yeah. And it's about patience, because it can sometimes be hard, of course. Alright, so as this talk was named 9 ways of course I scouted some more techniques after given title. So you get some bonus as well. Okay, so I guess few of you know kunngjøring, Norwegian. So this test name says the deadline for kunngjøring is 4 weeks. And this is a thing that the customer, one of the domain experts from the customer explicitly said to me. She said exactly this sentence. And if it were wrong, then she would tell me immediately, no, it's 5 weeks, or it's 3 weeks, or whatever. Like, I can show my test, okay, I can show some of my test names to the customer, get immediate feedback whether am I right or am I wrong? Have I understood it correctly? Yeah. And this is another one. Properties mainly follow the same rules. Monovision. So like, as a developer, I tend to think either this is right or it's wrong, right? We have this very logical way of thinking as programmers, as developers, engineers, whatever you want to call us. But sometimes it's good enough for, at least for method names, test names, that it's mainly the same. This is also an exact quote from a domain expert. It's mainly the same way, so it's useful. Not perfect, but useful. The same way of thinking, you will do stupid things, and that's okay, perfectly fine, as long as you learn from it. Yeah, and be consistent. By that I mean, in order to get all your legacy code and test, you can't just say, oh, I'm having a bad day today, so I won't be testing my code today, or like, oh, this code is really hard, so I won't, like, oh, we haven't changed this code to same to test before, so I won't be able to test it. Like, no excuses, just do it. But of course, you shouldn't do stupid things. Like, don't be testing Hibernate. Unless you're working on Hibernate, you don't have to test Hibernate. Unless you're working on Java, such Java is probably not wrong. It's probably your code, it's probably you. Oh, sorry, not you, not your code, your system. Like, don't start testing things that doesn't seem useful, stop doing it. Like, we have an example from my project where I had a colleague, we had this expectation or requirement for quite some time that we should have a given number of test coverage on our code, which is useful, but like emphasizes the wrong thing. But like just was useful to get started. But he was a bit late. No, he was very lazy. When someone told him that, okay, you haven't written test for this code, he went back and added 800 lines of system out print line and tested that method. And then he passed the threshold for test coverage. Like, don't do things like that. Don't do stupid things. Alright, so I think we're heading on 31 minutes, yeah, so we're a bit out of time. But for those of you who are interested in learning more about testing legacy code, I picked up quite some things from these two books, which is Refactoring by Michael Fowler and Working Effectively with Legacy Code by Michael Feathers. Both of them are 20-ish years old. Refactoring just came in a new version, but that's JavaScript, so not saying it's still useful. Both of these books are 20-ish years old, but I read them a couple of years ago and they're still hardly dated at all. There's so many general things that haven't really changed to do object-oriented programming since 1990 2000. There are lots of more techniques that I haven't been talking about today. We could do like several of these talks with using these books. And if you want more modern stuff, head on to Twitter. Because on Twitter, there's a big testing community. And the testing community, I have as a developer and tech lead, learned a lot from testing community on Twitter. So I just named a few of the most, other ones I learned the most from here. Lisa Crispin, Lisa Hockey, Indie Jones, Miles Behavior, there are many more. So the testing community is also very active with it, and they create lots of great content. Are there any testers here, by the way? On development? Good. Yeah, by the way, your testers will probably be the persons your testers will be the persons you want to be friends with. Like, whenever you can make their days easier, that's good for you also, I think. By that, we're heading into my key takeaways. Like, if you have been sleeping through the entire talk, or like you might have been wandering off to Jamaica or Cuba or something, on the beach somewhere, these are the three things that I want you to remember when I'm done. That good code design improves testability, and that's the first thing. Doing TDD of spaghetti code is just big quotation marks, of course. Doing TDD plus testing spaghetti code. And the first one, the last one, is like write test for your legacy code. I'm really sure you should do it. You can do it, and please go home and do it, so that you know that it's working. Thank you very much.
Thank you very much, Matt. And you know, we have a tradition here. We give T-shirts with our group for the best question from the attendees. So, any questions? From
Thank you for the talk. My question is more practical. So, what's the ratio between when you're working with legacy code, how much time you do like writing tests, refactoring, understanding, and actually coding something new? So, I'm just curious. So, in my experience, it's take a lot of time to coverage things that was not covered before. So especially with spaghetti. So what is your experience here?
Yeah. Well, yeah, that's my experience as well. Like first difference in like if I'm doing a bug fix or like changes into existing code or new code, that's like a big difference. But whenever I'm working with bug fixing and such, yeah, I'd say I guess I spend much more time understanding the existing code than writing new code. Yeah, like maybe 80% or so, I'd say. That's like that's part of the question. Like, and yes, it is hard to write this. So like it can take quite some time indeed. So it's a great question because like it gets me thinking. Well, hopefully you don't have to write this for like you don't have to change that many things at once. I guess that's the main point is that if you have this long methods and you're changing, like looking at you don't probably not have to change everything, but you can change a bit of it. So that's you can slice it. That's improves like that makes it much more capable. So then you can handle it. Kind of a question.
So you estimate somehow time to, for example, or I don't know, manager asks you how long you will do this task and you need to cover. So how do you estimate this?
Yeah. So what we do is that we estimate with a bit of like improvement time. Like okay, so we estimate that this task would be 2 hours just fixing it, but then 1 hour to improve, so that we have the principle, we follow the principle of leave the code base a little bit better than we found it. So that every time we do a change, we make the code base a bit better with some refactorings or renamings or testing existing code. So like we have this acceptance from the customer that yeah, you're using some time extra now, but in the long run, you actually can maintain the system and it all those. So yeah, it's the right fit.
Thank you for your speech. My name is Alex. My question is about the alignment of the tests. When you have at the bottom unit tests and functional tests and end-to-end tests. In practice, when you have this legacy code, you can't start from the bottom. It is easier to start from the middle, from the functional tests, cover somehow, then you go downwards. You would want to change something to refactor. Functional tests help you to do this. And after that, you go to the unit tests and cover it all. So my question is, how do you start? From what level? When you reach meet this flexibility?
Yeah, that's a great question. I don't. Yeah, I agree with that. In many cases, like not always. Like I don't always think that you should start at the beginning, but that's if it's a project. That's one of the things. But, well, I have to admit that for me, I'm mostly in the habit of writing unit tests, not typically where I start. But like, so it's more like I start by writing unit tests and then find out, okay, this doesn't work. Like, I write unit tests and find out, oh, this is lots of database calls or lots of tangling, so it doesn't really make sense to write unit tests. Then I stop it and go back and write more functional tests.
Got it. And the second question, how do you help yourself to really understand the meaning of your code? Because sometimes, yes, you have a good design of the code, but the logic is spread among different classes, different places and packages and so on. Maybe you draw some diagrams or write documentation, but it's not a good practice because it's hard to keep it up. So what do you additionally use to help yourself?
Well, that's a great question and a hard one. What do I do? Well, what do I do? Well, yeah, right. I didn't write down what the code methods, like the diagrams as itself. What more do I do? Often I find that sometimes I sit with another developer, like pair programming with pair understanding. Like, or if I can find, if the person that wrote the code still is in the same company or available for the reason, and perhaps he or she will remember anything about it, so I ask them. Or and sometimes I do writing tests for that as well. Like, I write a test to understand what happens if I do this, what does the code do. Like, when that's like I don't understand the logic, I don't want to do that. Yeah.
So, thank you for your presentation. I got a practical question as well. What is the idea of code coverage? Because if you have a big code coverage, so it is a big chance that you will have to refactor your testing in the closest future. Thank you.
Yes. Yes, test coverage. Well, that's a might good and I talk about myself. But like general rule of thumb, which really isn't that practical though, is that I think it's that if your tests add value in any way, it's probably good. Like if you can change, but like you know if that you have too late, but if you want wrong tests, if you are afraid of changing something because you don't know if I or not. Like that's like okay. On the one hand, if you have tests that you don't find it to provide value, you have to probably manually if you find that you're changing things, you probably have to few like then of course the obvious number two question is okay, how do you know if tests add value? That's value. And you can do things that are like mutation testing, but testing tools that automatically flips your true to false and 1 to 0 so to see that it actually fails. Because like I've seen lots of tests that always agree because they aren't really testing anything. That's not useful. And also you have to balance that the more tests you have, the longer time to get to run. So it's a trade-off in many ways. But I don't really have a practical answer. Maybe someone in the audience says.